Okay, today we're working with the law of cosines. And you can see kind of here in the front, I actually have the law of cosines. They show three different laws, but if you look at it and as we work on it a little bit more, or three different formulas here, you'll realize that those three formulas are really quite similar. It's really about what angle we're going to give, be given. And we want to start saying, okay, we're going to look at the law of cosines here, and another hopefully goal that we're going to have today is we're going to look at Hero's formula to find the area. So Hero's formula has to do with area. Law of cosines are going to have to do with finding angle measures and side measures. So we use law of cosines when we have a side, an angle, and a side and the angle in between it. Also, we're going to use the law of cosines when we have SSS. Basically, we use it when law of sines doesn't work. Okay? We'll get to Hero's formula here in a minute. So here's my example. I want to show you, this is what I was talking about when I said sometimes we have two sides and the angle between it. So this is an SAS example that I can say, oh, okay, law of cosines is what we want to work out here. So my b squared here would equal my a squared, 12 squared, plus my c squared, 23 squared, minus 2 times that a time, or b, oh, I'm even lost, 12 times 23 basically, and then times the cosine of that inscribed angle, 119. We just get to just plug all of this in to our calculator kind of as it appears. So let's do that. All right, so we had 12 squared. We had plus 23 squared minus 2 times 12 times 23. And then we said times the cosine this time of 119. Okay? We get our answer there, and we have an answer of 707.9. And you might say to yourself, that seems a little big. It is. We actually need, let me see if I got that right, 2, 12, and 23 minus 2 times 12 times, oh, and I just saw a mistake. It did look too large to me. So I'm actually going to go back here. I found my mistake, and I apologize, guys. I'm going to go back and fix this. I had a 3 where I should have had a 23. Sorry about that. I wonder if I can get to it. So I want to insert a 2 there. So I have 23 now. Oh, let's see if I get a better answer. That looks like a better answer. 940 does look like a better answer there. Now I need to find the square root of that answer to see that, okay, does my answer make sense? 30.66, 30.7. Now it's important to go back and go, wait a minute, does that answer make sense? Does it make sense for B to be 30.7? And actually the answer is, yeah, it does make sense, 30.7, because that does look reasonable with the 23 and the 12. 30.7 is the answer for our B. So we're going to move on. All right. Now we have an answer here, or we have a problem, excuse me, where we're having to draw our own triangle. And for the test, you're actually going to have to draw your own triangle quite a bit, and this is pretty common. And you're going to just need to mark an A, B, and a C. Don't worry about it being to scale. Don't worry that, oh, my A doesn't look like 39 degrees, my C doesn't look like 14 units long, and my B doesn't look like 12 units long. Don't worry about that at all. All right, that doesn't matter if it's drawn to scale. Okay, you might notice here that again we have side, angle, side. Look at my two sides I've been given, and then the angle between them. So again, side, angle, side is a good indicator that we are going to be using our law of sines. The problem here is we first want to solve for this side A. Okay, so side A is my first thing that I'm going to solve for. A squared would equal the other two sides squared. So I'm going to say 12 squared plus 14 squared minus 2 times that 12 times that 14, and then times the cosine of that inscribed angle, cosine of 39. Okay, when I plug that one into my calculator, I get an answer where the a squared is 78.9, and then that makes my a equal to 8.9. Okay, 8.9 we can work with. Now that we know a here is 8.9, now we can kind of switch it up and we can use law of sines, because now we can say 8.9 over the sine of 39 is equal to, let's say, 12 over the sine of b. I could just have easily had said 14 over the sine of c. It really doesn't matter where we're solving. So what I'm going to do is I'm going to do cross multiplication. I'm going to multiply these two together and divide by this. So what I get here in the end is I'm going to go 12 times the sine of 39 divided by 8.9. I get for an answer that the sine of b here is equal to 0.8485. Okay, well, that doesn't look right. That looks weird for an angle. Well, it is. What we need to do here is we need to say then that means that b is the sine inverse of that 0.8485. So on my calculator, what I'm going to do, and I'm going to show you here, I'm going to have the second, and I'm going to do the second sine for the sine inverse of that 0.8485. All right, when I hit enter, I get 58 degrees for my answer there. And so that's what my answer is, that okay, my angle is 58 degrees. What's nice here, all right, so my angle here is 58 degrees, is now I just have to use my 180 rule to say what is my third angle. 39 minus 58, 180, excuse me, minus 58 minus 39 turns out to be 83 degrees. So my missing angle, my angle C, was 83 degrees. All right, so those are my three angles that I had in my one missing side. If you remember, we're almost always looking for three things. So the big thing we had to remember how to do is right here, how to do this sine inverse. So remind yourself, whenever you're looking for an angle, you're going to be using an inverse of a sine, cosine, or tangent. So whenever there's an angle, we're going to be looking at a sine inverse of sine, tangent, or cosine. Mostly sine and cosine for this. So this is a good example of that. We have a triangle here, and we're given the three sides. So here's my A, my B, and my C. And we're given that A is 19, B is 24, and C is 22. Okay, and you're being told, please solve this triangle. We are missing all three angles. Okay, so we're missing what are these three angles. And this takes a little bit of time here, but I think we can work this out. So what you always want to do, and this is kind of an important idea, is that you always start with the largest angle, with the largest one. Okay, because if it is an obtuse angle, you have to solve for it first. It's not always going to be an obtuse triangle or an angle in the triangle, but if it is, that's the one you have to start with. You always know the largest angle is always across from the largest side. So in this case, we're going to start with angle B. We want to find the measure of angle B first. So what I'm going to say is that means that b squared is equal to a squared plus c squared minus 2ac cosine of that angle B. So here, my b squared is 24 squared. My a squared here is 19 squared. I'm adding the 22 squared. I'm subtracting 2 times the 19 times the 22, and then taking it times the cosine of my b. So what I see as the most common mistake is I'll see students say, I'm going to do all of this together. Be careful about that. You can't do that. You can't just multiply all that together. Okay? You have to kind of do it in parts. So let's kind of do it in parts here. 24 squared is 576. Okay? 19 squared plus 22 squared. Let me do that part. That is 845. Okay, let me do this part. What's this part right here? Let's just do that. Negative 2 times 19 times 22. I got a negative 836 for that. And that's being multiplied by the cosine of b. Okay? Now I still have students who say, oh, you just have to go 845 minus 836 here. But then the same students I've seen a lot of times, if I kind of go off to the side and say, hey, if I gave you a problem like this, 5 equals 4 minus 3x, and I said, please solve it. They wouldn't say, oh, that's 5 equals 1x. They would say, oh, what I need to do here first is I need to subtract 4 from both sides. Then I'm going to divide by a negative 3 on both sides. You need to think about this when solving this type of problem here, okay? We need to think of it just like that. So what we have to do here first to solve this problem is we're going to start by subtracting 845 from both sides. All right, so we're subtracting 845 from both sides. We get for an answer here negative 269 equals negative 836 times this cosine of b. Okay. I need to find out alone what is cosine of b. So I'm going to take it, I'm going to divide both sides here by negative 836. Okay, negative 836. So I get for an answer here positive 0.321776. That's what the cosine of b is. So what I need to do is to do that second inverse. Now let me show you kind of a shortcut. What we did here when we were finding this, at one point I took negative 269 and I divided it by a negative 836, and that's where I got this answer of 0.32177. I want to know what the cosine inverse is. So what I do here is I go second cosine, and then I go second, the negative sign, right above the negative sign, you'll see that ANS, that stands for answer. So I want to take the cosine inverse of the answer. And that tells me that what I was dealing with here was 71.2. So in other words, my angle B is 71 degrees. So what I can do here is say my angle B is 71 degrees. Now that's actually pretty powerful because, and I'm running out of space here, but what it does is now to find either angle A or angle C, I can use law of sines. So I can say 24 over the sine of that 71 degrees equals 19 over the sine of A. Okay, so that really helps me to know that what I need to do to solve that is take 19 times sine of 71, divide it by 24, and then take the sine inverse of that. I get the measure of angle A in the end here is 48 degrees. Well, if this A is 48 degrees, the 180 rule says the only thing for measure of angle C has to be 61 degrees. And now I found the measures of all three angles, okay? And that's really helpful. Let's move on here. All right, so I am going to show you the assignment here. I'm actually going to pause it, and we're going to have um, a second video with our information with our information for finding the area. And I changed my mind. I'm actually going to talk about the area here. I think I have enough time in this because this actually goes pretty quickly. Hero is a Greek mathematician who came up with this amazing formula that says you can find the area of any triangle when you know the measures of the three sides. There's Hero here, and sometimes it's called Heron, or just it's spelled differently. So what we're looking for Hero's formula is it says k equals the square root of this s, and then the difference between s in one side and s in the other side and s in the third side. What s is, it's called the semi-perimeter. All right, that's why the s, which means half of the perimeter. So first thing we have to find here is what's half of our perimeter. So to figure out s here, I'm just going to take 71, add it to 84, add it to 95, and then divide it by 2. Okay? In this case, my s turns out to be 125. So in my case here, my s is 125. All right. So I just have to fill out the formula now. My k would equal the square root of s, 125, and then I just need to take 125 and subtract all three sides, just making sure I subtracted each and every side. Okay. And then I just can plug this into my calculator really exactly as it appears here. All right, let's give that a try. So we're going to take, I'm going to clear this, I'm going to take the second and I'm going to take the square root. So right away I'm even going to take the square root of 125 times, and now I'm going to put the parentheses in there, 125 minus 71, and then times 125 minus 83, and then times 125 minus 95. All right, and I'm going to hit enter. Oh, I made a mistake. I didn't put enough parentheses in, I think. I have two multiplication signs there. Sorry about that. There we go. That should fix it. There we go. 2916. That's what I got for an answer here. So my answer here, oh, and I bet I put 83 for whatever reason. People, I put 83 instead of 84. I have to go back and fix this. This is a good thing. I can go second enter, and it's going to enter in everything. And I'm realizing that right here, I put in an 83 instead of an 84. I'm not even sure why I did it, but this is a good example of how we can solve it. Now if I hit enter again, 2881.4, now that seems reasonable. So our answer here should have been 2